Hello everyone, today we're going to solve the problem, find largest value in each tree row. So the problem says, given the root of a binary tree, return an array of the largest value of each row of the tree. So basically, for each row, just return the max. So if you go for this example, we see that for the first root row, it's the only node, so we just return 1. In the second row, we have 3 and 2, and we return 3 because it's the highest one. And then in the third row, 9 is the highest value, so 9 is added to the result list. The steps are pretty clear here. For each row, get the max. So if we are able to separate out each row and get the max of each row, we can get the result in our result list. And this is done, if you're familiar with level order, by doing level order and getting the max of each row, basically. And how does a level order work? If you're not familiar with level order, I'm gonna explain in the code and here how to do it. How to redraw it. So basically, level order uses a queue. So using the queue, we're going to be able to determine where does a level stop. So the first step is to add the root, and then given that, we're gonna get the size. So in this first iteration, the size is 1. So we get the size, and then we pop from the queue. So we pop, and then now we're here on the root tree. And for this node, we're gonna check, does it have a left child and a right child? So if it has a left and a right, and then since this one has both, we're gonna add both, starting with the left, and then that's it. Now the second iteration, we're gonna start by getting the size. We know that it's 2, so we know that there's gonna be 2 nodes on this level. So we're gonna start by emptying that level. We empty, we check this, we see that 3 has 5 and 3 has children. So 5 and 3, and then we go to the 2, we pop, and then we see that it has 9 as a child. Now we're done with the first 2 levels. We're gonna move on to the third one. So we're gonna get the size 3. So we know that there's 3 nodes on this level. So we're gonna pop 5, 3, 9. So that's level order. And the only thing we need to change is that for each level, we need to get the max and then add that to the result list. Alright, so here we are. So as I said, we need a queue for this. So it's going to be a queue of 3 nodes. New linked list. And I'm going to initialize the result list of integers. Express. I'm going to go ahead and return the result. Here the first step would be to add the root to the queue, but we need to first make sure that the root is not null. So if root is null, I'm gonna go ahead and return the empty list. However, if the queue is not null, you can go ahead and add that first node to the queue, and then we can go ahead and write our loop. So while queue is not empty. So in this loop, as I said, we're gonna need to get the size of the queue to make sure we know how many nodes are within the row or the level. So we're gonna do size is gonna be queue size, and then with the size we can go ahead and loop through the nodes, or I is less than size. But before we loop through the nodes, we need to make sure to initialize the max, since we need to the max of each row. So we're gonna do max is going to be equal to q.peak dot val, so that we get the first value in the row as initializing value. Then here we can go ahead and loop through the nodes and pop them out of the queue. So pull, and then here we need to make sure that the max value is the max between the current value and the old max. All we have to do left here is check if the current has a left and a right child, and if it does, we add it to the queue. So if it's not null, we can add it to the queue. Left. Same thing for the right side. Right. And then at the end of the loop here, we are sure that we got the max of the row, so we can go ahead and add the max to the result. And then outside the loop, we already returned the result, so we can go ahead and run this. You can see the solution passed. So thank you very much for watching the video. Please leave any feedback in the comments, and thank you for watching this video on my channel. See you around.